quadratic function models the height in feet of an object above the ground in terms of time in seconds after the object is launched off an elevated surface. The model indicates the object has an initial height of 10 feet above the ground and reaches its maximum height of 1,034 feet above the ground 8 seconds after being launched. Based on the model, what is the height in feet of the object above the ground 10 seconds after being launched? So these kinds of questions are quadratic regression. So we need to model a quadratic function. Sadly, I don't believe we can go to Desmos and use the regression feature on there because we only have 2 points given. Now you might be wondering how many points we were given. Let me point you out to why I'm saying we have 2 points. The first thing is initial height of 10 feet. Initial height means the x value is 0. So when x is 0, the height was 10. The second point that we're given is the maximum height. That's the vertex of it. And it says after 8 seconds, we were at 1,034 feet above the ground. So those are the 2 points that I'm referring to. Now, to do a regression on Desmos, you need 3 points. Otherwise, you will have the incorrect equation if you try to use 2 points. Just to be clear, for linear functions, 2 points are sufficient. For any other function, you need more than 2 points, 3 or more. Okay, so seeing that we have to do this manually, let's hop into it. Anytime you know the vertex, and we are given the vertex, we should think about writing the equation in the vertex form of the quadratic function. And again, it looks like this, whereby we need to have a value for a, value for h, a value for k. Recall h and k are the vertex values, h and k. So 8 is h and 1034 is k. Okay, so with that said, let's go ahead and plug in what we do know. A, x, you always switch the sign of h. We had a positive 8, so I'm going to write in minus 8 squared plus the k value, which is 1,034. So good news is we found 2 of the 3 things that we needed. We needed k, we have it. We needed h, we have it. But what about a? What are we going to do to figure out what a is? So this is where we need an additional point. Well, I say additional loosely, but really we could just use one of the original points to figure out the value of a. Now, always use the one that seems easier to work with. In this case, it would be 0, 10. Let's plug those into the current equation. So y is 10 and x is 0. So let's go for it. 10 equals some a value, 0 minus 8 squared plus 1034. You do the math here, you have 10 equals 64a plus 1034. Now, if you're lost on how I got this 64a, let me show you real quick. 0 minus 8 is negative 8. Negative 8 to the second power is 64. 64 times a is 64a. All right, so then let's continue. You subtract 1034 from both sides. We end up having 1024 equals 64a. Now we're going to divide both sides by 64. Oh, that should have been a negative 1024, by the way, because 10 take away 1034 is negative 1024. All right, and then when you divide these, your a value ends up becoming negative 16. So that allows us to then write the equation fully over here. So our quadratic equation is y equals negative 16, x minus 8 to the second power plus 1034. And now to answer the question, we wanted to know the height of the object after 10 seconds. All right, all we do is plug in 10 right here. Remember, x stands for time, and then do the math. You can use your calculator if you want to. 10 take away 8 is 2. Then you're going to square that plus 1034. When you do the math, you have y equals negative 16 times 4 is negative 64 plus 1034. When you do the math here, negative 64 plus 1034 is 970, which makes C the correct answer to this question.